All right, hello everyone. Today I'm tackling Law of Sines and Cosines, a little mixed practice. It's been a while. So remember that we can use the law of sines or cosines for any kind of triangle. We're just trying to be conscious of, do we have an angle with a side opposite? If we do, then we can use the law of sines. But if we don't have an angle with a side opposite, so if we have side angle side marked or side side marked, for example, then we have to use the law of cosines. So here in my instructions, use the law of sines or the law of cosines to write an equation, solve for the missing side or angle measure. If the triangle is ambiguous, provide both measures. You may round all intermediate steps to the nearest 100. So I'm always okay if you want to build off of a precise answer in your calculator, that's fine, but you can also just record all of your intermediate steps to the nearest 100. All I really ask here is give me a nice clean paper trail so that I understand what your thought process is. All right, so the first one up with what is marked, I have side, angle, side, right? Two sides with that included angle. So I can see, okay, side, angle, side is what it's marked as. So am I going to use the law of sines? Do I have an angle with the side opposite? Well, I have no known angle with its opposite side marked, right? So I can't use the law of sines. I have to go through the law of cosines. Okay, so I'm always conscious of what am I solving for? I'm solving for the side opposite this angle. So if I first just lay out the law of cosines, because it's been a while, I know it's going to be a squared equals b squared plus c squared minus 2 times b times c times cosine a. And I'm always solving for either here, an unknown side, or here, an unknown angle. The b and the c are just the other two sides. So here I'm solving for x. So here's my x. X squared is equal to, well, I have 2 squared plus 3.5 squared minus 2 times 3.5 times cosine A. A is 70. Let me fill that in. Good thing I brought my white up. A is 70, so I can fill that in. Okay, so what's nice about this is that I can plug straight into my calculator. So here we go. Let me just clear whatever was in there. So I can say 2 squared plus 3.5 squared minus 2 times 3.5 times cosine 70. Oops, didn't mean to do inverse cosine, regular cosine. Cosine 70. Okay, so there we go. So I get about 11.46. So let me record that to 2 decimal spots. X squared is about 11.46. Okay, and then if I want to build off of that precise answer, I need to take the square root of each side. So x will be about, and again, technically it's going to be plus or minus, but we're only interested in the positive because it represents a side length. So square root of that previous answer. So second answer, just like that, right? That's what I keep saying is, it's your Vans symbol. So hit enter and we get about 3.39. So that missing length right here is about 3.39. All right, next up. So what I have marked, I have two sides and I have a non-included angle. So I know that that is side angle. And the moment I see side angle, I know to be cautious because this is the time when the ambiguous case may or may not show up. For a triangle to be ambiguous, that means that we have two very different looking triangles that could be produced using the same information. So here I'm looking at this, I know it's side angle. I have an angle side opposite, so I can use the law of sines to solve. Write that clear. Law of sines. Again, I have an angle with the side opposite. Law of sines. Okay, And then I have to ask myself, is this going to be a case where it is ambiguous or not? So if I look at this for a moment, where would my hinge have to be? Well, my hinge would have to be right here. The hinge is always in between the two known sides. So then, here, that 42-degree pathway, that is locked into stone. So I have to look at this side that's 3. And I have to think, well, does it have room to swing into an alternate location? You saw me do this with a compass. So I had my needle here, pencil here, and I could swing into a second location right about here. Right? It would start here, overshoot, make this little arc until it connects to about right here. So we see that there is room to swing into that second position because the 3 is small enough to do so. So we know that it's going to be ambiguous. We're going to say yes, because the side opposite the given angle is smaller than the other given side. Okay, which again creates room for that side that's 3 to swing into that second location. So I'm going to have 2 possible triangles. Let me just kind of sketch out both of them so we can see them side by side. So I'll have this one, and then I'll have this one. So same given information, but they look totally different. So for this one, here's the 3, here's the 4, here's the 42 degrees. For this one, here's the 3, here's the 4, here's the 42 degrees. And I'm solving for x. So if I solve for x, I'm solving for this first triangle, the big guy right here that I've drawn right here. So if I'm solving for x, I can build my proportion saying sine x is to 4, just as sine 42 is to 3. So there's my proportion using the law of sines, and now I cross multiply. So 3 times sine x equals 4 times sine 42. And then I'm going to divide away the 3. So I have sine x is about. Okay, so let me plug that in. So I had 4 times sine 42, and then I'm dividing that by 3. So there we go. So I know that sine x is about 0.89. So then to solve for x, I need to take the inverse of sine along with that ratio to get to my angle measure. So here, again, there's 2 ways I could do it. I could build off of the precise answer in my calculator, or I could build off the rounded answer. I think for this one, I'm going to build off the more precise. So here I'm going to say inverse of sine along with that previous answer, that ratio, and that gets me 63.15 degrees. And I want to remind you that if you built off the rounded answer, that's not a problem. So this is giving me one of my 2 options. So I get this degree measure for x, or a second option. So remember where this is coming from. We just solved for this angle, 63.15. So that's right here, the 63.15 degrees. So then this side that was 3 could swing into the second location, right? And then I have an isosceles triangle right there. So the base angles, well, they'd have to match. So this would be 63.15 degrees as well, right there. And then all I'm really doing when I get to the other option, that angle here, is I'm taking the supplement of 63.15. So I'm just taking 180 minus 63.15. So 180 minus 63.15, and that gets me 116.85 degrees. Okay, so again, if you built off a rounded intermediate step, no problem. Your answer will be really close to mine. I just built off of what was stored in my calculator. If you're off by a few hundredths, that is okay. I'm checking your paper trail. All right, next up. So here for C, I'm looking at what is marked. I have an angle and another angle, and I have the side that's in between. So I have angle, side, angle. And I'm just checking, do I have an angle with the side opposite? And anytime that I have two angles, I actually do know the third one because my triangle has to add to 180. So my missing angle here has to be 60 degrees. So now I can see that sine 50 is 2x, just as sine 60 is to 3. So again, I had an angle with a side opposite, so I knew that I was using the law of sines. Okay, from here I'm just cross multiplying. So I get x times sine 60 is equal to 3 times sine 50. And then I'm just dividing away the sine 60 from both sides. Here I can go straight to my calculator, type that in. So here I have 3 times sine 50, and then I'm dividing that by sine 60. So here I'm getting about 2.65. So 2.65 right here. All right, last up, here I have 3 sides. I got side, side, side. I don't know any angles, so here I have to be using the law of cosines. So again, let me lay that out for you. A squared equals b squared plus c squared minus 2 times b times c times cosine A. Again, I'm always solving for either a side or an angle. And in this case, I'm solving for the angle right here. So I have to be conscious of where x is. What is the side opposite? That side opposite is 3. So that means I have a 3 squared first equals 3.5 squared plus 3.8 squared minus 2 times 3.5 times 3.8 times cosine x. Boom, just like that. And now I have to be very conscious of my order of operations. So these guys I can square and combine. I can add them. And I can do the same with this part right here. But I have to remember that this is a product. This is a package, so it's staying locked together. So right now I have 9 equals. Well, if I take 3.5 squared plus 3.8 squared, that's going to be 26.69. And then subtract. Here I multiplied the 2 times 3.5 times 3.8. And I get 26.6 times cosine x. Okay, a big mistake that I often see is I'll see students who try to combine here. But remember here that minus, this is a package, right? It's a product. It's multiplied together. So I cannot take that 26.69 and subtract 26.6 because that's attached to the cosine x. It's like if I had 10 minus 4x, I can't consolidate further. Right? If I just had 10 minus 4, sure, but not if it was 4x. So now I'm working to get this term isolated. So I'm going to take away the 26.69 from each side. So now I have negative 17.6 equals negative 26.6 times cosine x. Okay, and then from here I can divide away that negative 26.6. So I get that cosine x will be about 0.66. Okay, let me just show you what I have currently in my calculator. So I am right here. That is the ratio that I have right now. So in order to get to the angle, I use the inverse of cosine with that ratio, and it will give me that angle measure. So if I want it precise, I can build off of the answer I have right here in my calculator. So inverse of cosine with that previous answer, and that gives me a more precise value of 48.57 degrees. If you built off of that rounded intermediate step, that's really not a problem. I'm just going to show you how close you would get. So inverse of cosine with the 0.66. So right here, you're getting 48.7 instead of my 48.57 degrees. Okay, that's not a problem. I will take both of those answers. Okay, I just built off the answer that was in my calculator. So my answer is more precise. All right, let's move to that second sheet. So flip it over or pull out that second sheet. And here we're looking at some word problems. All right, so in problem 2, we have a building that is constructed on the top of a cliff. Okay, so if I start with that, here's my cliff, and then I got this building that is on top of it. So we'll just make it look like so. I will not judge your artistic ability. So if you just even wrote building there, not a problem. All right, the building is 300 meters high. Okay, so right here is 300 meters high. I'm just going to write 300 there. I'm going to remember that it's meters. Okay, a person is standing at ground level below the cliff and observes that the angle of elevation to the top is going to be 72 degrees. So top of the building, that angle of elevation is 72 degrees. So let's put someone maybe about right here and connect them to the top of the building. And let me draw in that triangle. Happens to be a nice right triangle. And that angle of elevation from that horizontal looking up, right, I know that that span is 72 degrees. Okay. So then we also have that the angle of elevation to the top of the cliff is 63 degrees. So if I draw that pathway in like this, just like that, so the angle of elevation from this horizontal going to the top of the cliff, we're told is 63. So if that's 63 then, and this full span has to be 72, this measure would have to be 9 degrees. So again, the 72 is that full span. So I'm just keeping track of that right now. Okay, let's see what else we know. How far away is the person from the base of the cliff? Okay, so that's the question that's being posed. So right now, I need to figure out how to work with what information I have right now. So if I fill in some of these angle measures, which I definitely can, I have a right triangle here. So if this angle is 63, right, its complement would be right there, so 27 degrees. So I can fill in that angle measure right here. I know that 27 and the angle right here, well, they're a linear pair, so they have to add up to 180. So here I'm at 153. Okay, I have this triangle right here, right, has to add up to 180. So if I take 180, subtract 153 and the 9, I get 18 degrees right here. Okay, so I've just marked up everything that I can, and the question that I'm being asked is how far away is the person from the base of the cliff? So ultimately I'm asked for this measure right here. So I'll call that X. But I don't have any measure for a side to help me get there. So I need to build off of something where I have a side marked. And I see that the only side marked is this 300 right in there. So let me draw that triangle off to the side. So I have this triangle, kind of looks like this. So I have that this is 300. I know that this angle is 153. Here I got my 18. And here I have my 9. So I have to stare at that and think, well, how would that help me connect to get to X eventually? And I see, to X eventually. And I see, oh, well, I could solve for this portion right here, the person to the base of the building, right, the top of the cliff right there. I'm going to call that Y. So I see that I have an angle with the side opposite. I could use the law of sines to get to what I've marked as Y. So building my proportion, I can say that sine 18 is to Y, just as sine 9 is to the 300. Okay, cross multiply, and 300 times sine 18 equals Y times sine 9. And then I'm just dividing away the sine 9. So I'm going to get that Y is about, let me do my little crunching. So here I'm saying 300 times sine 18, and then dividing by sine 9. So right there I get 592.61 meters. So I can add that detail that this is 592.61 meters. So if I build off of that, now I have this right triangle. I know that this is x. That's ultimately what I want. I know that this part of it is 592.61. It's what I just solved for. This is 63 degrees, and this is 27 degrees. Okay, so I can go back again to my nice old-fashioned basic trig. So basic trig, it's a right triangle. So I'm just returning to my SOHCAHTOA. So if I call this right here my reference angle, then I have an adjacent side and I have my hypotenuse. So I can use cosine. So I can say that cosine 63 equals my adjacent over my hypotenuse. Just like that. I like to visualize it as a proportion, and then I'm cross-multiplying. So I'm saying that x will be equal to 592.61 times cosine 63. So if I look at what's currently in my calculator, here I can build off of that previous answer because it's nice and precise. So if I build off that and I multiply by cosine 63, I end up with an x value of about 269.04 meters. So again, if you had built off that rounded intermediate step, not a problem. Just give me a nice clean paper trail in the end. All right, next up, here we go. So looking out at a balcony, the angle of elevation to the top of the next building is 22 degrees. And the angle of depression to the bottom of the building is 29 degrees. If the building is 200 feet away, how tall is the building? So let's make ourselves a pretty picture. So I have a building over here on the left. And I got a building over here to the right. Just dropping myself a nice visual anchor so I can see what's going on. Here are my two buildings. All right, so looking out at a balcony, so say that here's my beautiful balcony going to the other building, that horizontal pathway. The angle of elevation to the top, so going to the top, is 22 degrees. Okay, this is a right angle right there. The angle of depression, so from that horizontal looking down to the bottom of the building, is 29 degrees right here. Okay, if the building is 200 feet away, so here's my 200 feet, how tall is the building? So I could call this X and I could call this Y. So what's nice here is that I really have two right triangles. So probably easier for me to visualize them as separate triangles, solve for the X, solve for the Y, and then add those two numbers together. So let me first just draw them out as two separate entities like this, where here's my 29, here's my Y, here's my 200 feet. So for my first one, from this reference angle, opposite adjacent, I'm using tangent. So I can say that tangent 22 equals x over 200. So here's my proportion, cross multiply. X equals 200 times tangent 22. So that's going to get me about 80.81. Okay, over here for the second one, from right here, I have an opposite and an adjacent. So again, I'm using tangent. Tangent 29 equals y over 200. There's my proportion, cross multiply, and y equals 200 times tangent 29. So y will be about 110.86. So again, I want the full height of the building, so I have to add the x and y together. So I have to add that 80.81 and the 110.86, which will get me 191.67 feet total, which would be the height of my building. All right, next up, this one we've seen a couple of times. So you build a triangular garden. The sides of the garden are 8 feet, 13 feet, and 10 feet. So remember the hint that I've been giving you when you draw it, make the longest side the bottom. So I'm going to make that long side the 13. Where I put the 8 and the 10, it really doesn't matter. I'm just going to draw it like this. So here's my 8 and here's my 10. All right, we're asked for the area of the garden. So area is always 1/2 the base times the height. So if I've drawn it out so that this is my base, I know that eventually I'm going to need my height. But to help me get it, I'm going to need an angle measure. So let's say that I want this one right here. I'm going to call it x. So since I'm solving for an angle measure, I know no other angles, and I have 3 sides, I have to use the law of cosines. So I'm looking at my side opposite that marked angle, and I see, okay, that's the 10. So I have 10 squared is equal to 8 squared plus 13 squared minus 2 times 8 times 13 times cosine x. So I have 100 here is equal to, remember that I can combine these terms and these guys here. So I have 64 plus 169, so 233. And then take away 208 times cosine x. Right? I'm following my order of operations. So I can take away the 233 from each side. So negative 133 is equal to negative 208 times cosine x. From here, I can divide away the negative 208 from each side. So now I have a cosine x is going to be about 0.64. So I need to take the inverse of cosine with that ratio to get my angle measure. So first, let me just type that in. Let me get caught up to here. Okay, so here we go. I have 133 divided by the 208. So I see what that ratio looks like precisely. So I can say inverse of cosine along with that ratio, and that gets me a more precise answer of 50.25. Again, building off a rounded answer, not a problem. So right here, that's 50.25 degrees. Okay, and then I'm going to draw in my height like this, and I'm going to picture one of those 2 right triangles. So I'm going to picture this guy right here, where this is 50.25 degrees. That is 8, and this is, I'll call it y. That's the height that I was solving for. So if I use my basic trigonometry from here, I have an opposite and a hypotenuse. So I can say sine. Sine 50.25 equals y over 8. Okay, make it a proportion, cross multiply, and y equals 8 times sine 50.25. So y is about. Okay, right here, again, I have it stored in my calculator. So I can say 8 times sine of that previous answer right there. So here I'm going to get 6.15. So y is about 6.15. Okay, and then pulling it all together, now I need the area of the triangle. So 1/2 the base times the height. So here I'm looking at my base. My base is that full 13. And my height is the 6.15. So here I'm going to multiply that across. 1/2 of 13 times, again, I'll build off that previous answer, make it nice and precise, don't round till the end, and I end up with 39.98. I'm talking area, so I have to say units squared or square feet like I'm writing right now. Okay, again, building off a rounded answer, not a problem. Just leave me a nice clean paper trail. All right, I hope you guys are doing well. I miss seeing you in real life, and have a wonderful rest of your day. I hope to see you soon.